Hey, welcome back. This is Mr. Kelly. Today we're doing an easy one. This was so easy. We just did so many hard ones. This one's easy. It's called the Pythagorean identity. We're on page 825. This is Module 4, Topic 2, Lesson 1. Here's what we're going to learn today. We're going to prove the Pythagorean identity, all right, which is actually sine squared plus cosine squared equals 1. We'll get to that. And we're going to use the identity to determine all of the trig ratios for a given measure of an angle in a quadrant. So we're going to do the review. We're going to determine the value of each. The sine of 45 degrees. Again, we're on page 825. All right, number one, the sine of 45 degrees. As we recall, the sine ratio is the opposite side over the hypotenuse side. The ratio of the opposite over the hypotenuse. Let me get my pen going here. So let's write that down just so we remember it. We have to remember this. This has to go into our brain here. It's the opposite side over the hypotenuse. And this is our special right triangle for a unit circle, which means the hypotenuse is 1. So the angle we're looking at is 45 degrees. The opposite would be radical 2 over 2, and that is all over the hypotenuse, which is 1. Well, we know that anything over 1 is itself, so I'm just going to call this answer radical 2 over 2, and we're done with that one. Now, the other triangle that we have to know is the 30, 60, 90. And again, this special right triangle, you might know it like this. This is how I draw it on papers. If we put the 30 right here, generally what I will do is put the 1 here, the 2 here, and the radical 3, right? But if we're dealing with a unit circle means that the radius is equal to 1, which is why this line right here, the hypotenuse, has to be a 1. Well, how do we get to that? We just divide each side by 2, right? And so if we divide all the sides by 2, then we get the triangle that is given for a unit circle right here. We want the cosine. As we recall, the cosine of 30 would equal the adjacent side over the hypotenuse, right? Why is my pen not working? So the adjacent side to 30 is the side that's next to it over the hypotenuse. So it's radical 3 over 2 over 1, or simply radical 3 over 2. Now, eventually you have learned through Mr. Sullivan that the sine ratio is the same as the y value, right? And the cosine is the same as the x value in a unit circle. Well, that's going to become very important as we prove an identity here around the unit circle. We should know this, right? Unit circle is a circle with a radius of 1. So if we go out, that's 1 unit. If we go up, it's 1 unit. If we go diagonally here, it's also 1 unit. Okay? That's why it's called a unit circle. We're going to complete the table. This is really important that we memorize this. You should know this. And I'm going to give you a little hint. You should know it very well when you take your mastery check. We're on page 826 now. The sign, we just want to know where things are positive and where things are negative. So I can tell you that in quadrant 1, everything is always going to be positive. We can go right down that line there. Okay, the x values, the y values, and the tangent here. So quadrant 2, well, quadrant 2 is over in this area. That's where the x value or the cosine is negative, right? But the y value is positive. Now, when we figure out the tangent, something we should know, the tangent of theta is going to equal the sine of theta over the cosine of theta. That is an identity that we know from before. So the tangent always equals the sine over the cosine. Well, if we look here, we know that the sine is positive and the cosine's negative. What's a positive over a negative? It's negative. Okay, let's go down to quadrant 3. Quadrant 3, we have the cosine, that's the x value, is negative. And also the sine value is negative. We have 2 negatives. But what's a negative over a negative? It's a positive. So when we calculate the tangent, we have 2 negatives. A negative over a negative is positive. So down here we get a positive. And now quadrant 4, which is down here, right? So the cosine or the x value is positive, and the y value would be negative because we're going down. And a negative over a positive is negative. So if you can fill this table out, that would be real neat. We have to memorize where things are, positive and negative. Now I'm going to show you something this really rattles up Mr. Sullivan. He does not like this when I show this, but I'm going to show it anyway. So we have a saying: all students take calculus Okay, all students take calculus. If you go around the circle, all students take calculus. This tells you which functions are positive. So they're all positive in the first quadrant. Look, all positive. And then in the second quadrant, only sign is positive. So we go to the table, look, in the second quadrant, only sign is positive. And then in the third quadrant, only tangent is positive. Third quadrant, only tangent. And then the fourth quadrant, only cosine is positive. That's another way you can remember if that helps you out. Whew. Well, let's look at the Pythagorean identity now. We're on page 827. It is the basic relationship, the sine squared plus cosine squared equals 1. Now we're going to kind of figure out what that means here. Going down, given the unit circle and angle theta, label each side the lengths of the right triangle in terms of sine and cosine. Well, we know that the x value is the cosine of theta, so we're just going to label that the cosine of theta. And the y side here, that is the sine of theta. This is stuff Sullivan already taught you, right? So we're going to state the Pythagorean theorem. You learned this a long time ago. This is the most famous theorem in math, which says that a squared plus b squared equals c squared. And that is true for any right triangle, which we have right here. This is why we're doing trig. Trig is the study of right triangles. So a squared plus b squared equals c squared. Well, let's look at this triangle we have right here. That would be that x squared plus y squared would equal, and in this case we get the radius squared. But we know the radius is 1, right? So we can just substitute. Now it says use substitution to demonstrate how the Pythagorean identity follows from the Pythagorean theorem. So if I substitute, r equals 1, so this would be a 1 squared. Okay, and we know that the x was cosine. So the way we write that is like this: cosine squared of theta plus sine squared of theta. All right, so I'm just substituting x for cosine and y for sine. And look what I get right here. We get, well, normally we put the sine first. Let me reread it. Everybody likes sine first. Sine squared theta plus cosine squared theta equals 1. That is our Pythagorean identity. It's that simple. Now, just some things I'm going to point out again. When we have cosine times cosine, we write it as cosine squared. We do not write this cosine of theta squared. If you write that, then you're squaring the angle, and nobody wants that. What we're doing is squaring the cosine, so we put it on the cosine of the angle, okay? But sine squared plus cosine squared equals 1. And this is probably, I guess I go on a limb here and say it's the most important trig identity that you will learn. Well, we're done with that page. Let's go to 828. Solve for each value to write the Pythagorean identity so that sine squared plus cosine squared equals 1 in two other forms. Well, we want, basically this is asking us, get sine squared all by itself. So if we have sine squared of theta plus cosine squared of theta equals 1, then I know I can subtract from each side in equal measure. So here's the middle of the equation. I'm going to subtract cosine squared theta from each side. And what does that give me? On the left, the sine squared theta comes down, and then these cosines cancel. I get the equal sign, and I get 1 minus cosine squared theta. So whenever I have an equation and I see sine squared, I can replace it with 1 minus cosine squared theta, right? All right, well, what else we got? We can do cosine squared as well. So sine squared theta plus cosine squared theta equals 1. If you want to solve for cosine squared, you can subtract sine squared from each side. Minus sine squared theta. And we draw the line. These would cancel. We would get cosine squared theta equals 1 minus the sine squared of theta. All right, well, that's pretty easy, right? So whenever we have, if we have the cosine, we can just plug it in here, and it'll tell us the sine squared. And if we have the sine squared, we can plug it in, and it'll tell us the cosine squared. That's easy enough. Okay, let's move on to page 829. And here's a worked example. Here's how we're going to use that Pythagorean identity to solve for unknown trig values. It says determine the exact value of cosine of theta. It's in quadrant 2, and they give you that the sine is 2/3. Well, it's this simple. We write out the Pythagorean identity. Sine squared plus cosine squared equals 1. They tell you the sine, so we substitute it. That is going to go in for the sine. So that's what you get right here. Then we calculate it. We can use a calculator. We subtract from each side. We get the cosine squared. Now, here's the part we've tried to impress upon you. When you square something and you're trying to solve and you got to take a square root, the answer could be positive or negative. By the way, how they get from this to this? I mean, I guess you could plug it in your calculator, but when you put that radical in, it's going to mess things up. You're just going to get a decimal. So really, you have to do it like this. The square root of 5/9 is going to equal the square root of 5 over the square root of 9, which equals, we're just going to leave the square root on top and call the bottom 3. So that's where that comes from, but it could be positive or negative. How do we know which one? Quadrant 2, and we're talking about cosine. So we know in quadrant 2 the cosine is negative. So our final answer would be negative square root of 5 over 3. Easy enough, right? Time for us to do something. All right, so now page 829. Given that the sine is 3/5 in quadrant 2, determine the cosine. This is very similar to the one we just did. Here's what we're going to do. We're going to write down the Pythagorean identity. So the sine squared theta plus cosine squared theta equals 1. But we know sine is 3/5, so substitute that in. So we substitute in 3/5 for the sine squared. By the way, we can do this math in our head. 3 times 3 is 9. 5 times 5 is 25. So 9/25 plus the cosine squared of theta is going to equal 1. We could subtract 9/25 from each side. We'll do that over here too. All right, I can do that math. These will cancel. Draw a line. We get the cosine squared of theta is going to equal 1 minus 9/25. Now, I know some of you don't like the fractions, right? If you need to, you can use your calculator, but 1 minus, make sure you use those parentheses, 9/25. Okay? And then we hit enter. That's a decimal. We don't want no decimals. We want fractions. So it tells us it's 16/25. That's the cosine squared, right? So the cosine squared is 16 over 25. That's what I get when I solve for cosine squared. So how do we get down to cosine? If I have cosine squared, we square root it. Now here's the part you got to be careful about. The cosine of theta is going to equal plus or minus, because when we take the square root of a square, we didn't know if that cosine was positive or negative, so we got to write both. And it's going to equal the square root of 16 over the square root of 25. But I can do both of those in my head. This is going to equal plus or minus 4 over 5. Now, that's the cosine. So I'm going to write that down. Cosine of theta equals. Now I got to figure it out. Is it positive or is it negative? Well, in quadrant 2, cosine is negative. We should know that. So the answer should be negative 4/5. And we're all done with number 1. How fun was that? Okay, so now I will hop down to number 4. And then you guys can finish 2 and 3 when I'm done. I'm going to do number 4 because it has some weird radical stuff going on here. So number 4, we're going to write out the same identity again. Sine squared theta plus cosine squared theta is going to equal 1. Now, they're telling us in number 4 that the sine is negative 1/10. So if we square that and add it to the cosine squared, it should equal 1. It's also in quadrant 4. That'll be helpful later. When I square negative 1/10 in the calculator, I'm going to get 1/100th. Okay, so 1/100th plus cosine squared of theta is going to equal 1. That means that the cosine squared of theta is going to equal 1 minus 100th. Well, I know that's 99 out of 100, right? If I take one whole and I subtract 100th, I get 99 out of 100. So now what? We got to take square root of both sides. When we do that, we get the cosine. I'm going to give myself a little bit of room here. Cosine of theta is going to equal the square root of 99 over the square root of 100. And I can't forget my plus or my minus. We'll figure out later which one. But now we have to simplify radicals. And we've done that before. So the square root of 99, what is that going to be? That is the square root of 9 times the square root of 11, right? Because 9 times 11 is 99. And that's all over the square root of 100. And I'm not going to forget my plus or minus because we got to figure out which one. So this all becomes plus or minus 3 radical 11, right? Because that 9, square root of 9 becomes a 3. The 11 just stays. And it's all over the square root of 100, which is 10. This is an ugly, ugly answer. But hey, it's in Ramstein blue, so what do you expect? We're in quadrant 4. Cosine in quadrant 4 is positive. So I'm going to write out the cosine of theta is going to equal the positive value of 3 radical 11 over 10. And that's it for number 4. Now's a great time for you to try some. Complete numbers 2 and 3 by yourself. Ready, set, go. Wow, check out that wild animal. Cool statue too. All right, this is what we get for a 2 and 3. You should get a negative 3/5 and negative square root of 15 over 4. The work's right here. So if you have a problem, put up a red cup and we'll come help you out with that. We got one more thing. We're now going to look at the tangent of theta, and we know that what? Well, we know that y is the sine of theta, right? We know that. And we know that the x value is the cosine of theta in the unit circle we're talking about right here. All right, so y over x, we have our relationship of the tangent of theta equals the sine of theta over the cosine of theta. Wait, why is that? Well, let's look at our picture here. So tangent of this is the opposite over the adjacent. We know that that's what tangent is, right? Opposite over adjacent. So because it's opposite over adjacent, it's y over x, which is the sine over the cosine. So we can use that little property there to figure out tangents now. We can do sines, cosines, and tangents. We're also going to still use our Pythagorean identity of sine squared plus cosine squared equals 1. So number 2 here, given that the sine of theta equals negative 1/4 in quadrant 3, determine the tangent of theta. So let's write that down. Sine squared of theta plus cosine squared of theta equals 1. We're going to plug in negative 1/4 here. And we're going to square it. And then we're going to find the cosine. All right. So when we do that, we already did this problem, right? So cosine squared of theta in this example would equal 15/16 after I square that and move it over. When I find the square root, cosine of theta is going to equal the square root of 15 over 16, which equals, oh, can't forget my plus or minus here, plus or minus, which equals plus or minus the square root of 15 over 4. Now, it's not plus or minus, right? It's one or the other. So we are in quadrant 3, so I know that the cosine here would be negative. So it equals negative 15 over 4. Whoa. Okay, we have one last thing here on page 830. We're going to look at tangent now. Consider the diagram. What? I'm considering you. We know that the y value, we already know that, right? That the y value is the sine of theta. We have figured that out for a unit circle. And additionally, the x value is the cosine of theta. So we also know that the tangent of theta, based on our geometry, right? Tangent is the opposite over the adjacent sides in a right triangle. It's the ratio of the opposite over the adjacent, which in this case, the opposite side would be y, and the adjacent side would be x. But guess what? We know what y is. Y is the sine of theta. And x is the cosine of theta. So, long story short, the tangent of theta is going to equal the sine of theta over the cosine of theta. How cool is that? That's always true for everything. Wow, that was great. Let's do number 2. Number 2 says, given that the sine of theta equals negative 1/4 in quadrant 3, determine the tangent of theta. Well, yeah, we're going to use this property right here so that we can start figuring out tangents as well. Yay. All right, so the sine squared plus the cosine squared of theta equals 1. What do they tell us here? Sine is negative 1/4. So we're going to plug that in right here. Negative 1/4 squared plus cosine we don't know, right? So the cosine of theta is going to equal 1. So we did one like this. We can solve for the cosine squared. Cosine squared here would equal 15 over 16. I think you can figure that out. We take square roots of both sides. We could get the cosine of theta is going to equal plus or minus, we'll deal with that in a second, 15 over 16, which is, in this case, let me put that plus or minus so don't forget. What do we got? Quadrant 3. So I know that the cosine, which I'm figuring out, would be negative. So this would be negative radical 15 over, that's just a regular 4. All right, so we know the cosine, but it says figure out the tangent. But we know the cosine. Let me write it down. Negative 15 over 4. But the tangent's just going to equal what? we know the tangent equals the sine over the cosine. We already know the sine, they told us. We already know the cosine, we figured it out. So the tangent of theta is equal to the sine of theta over the cosine of theta. So that's going to equal what? I'm going to use parentheses to make sure I'm extra careful here. Negative 1/4, that's the sine of theta, over, we figured out cosine, which is negative 15, square root of 15, over 4. That is an ugly fraction. You know what I'm going to do to fix this fraction? Let's see, when you divide by a fraction, you can multiply by the reciprocal, right? Or I'm just going to multiply by 4 over 4 here. When I do that, these will cancel, these will cancel. I'm left with a negative over a negative. The negatives cancel. So much canceling. Cancel culture here. We get 1 over the square root of 15. But we can't have a square root on the bottom. We can't have a square root on the bottom. So we multiply. We rationalize the denominator. We multiply by the square root of 15 over the square root of 15. Final answer here, square root of 15 over 15. Now, let's write that out. Tangent of theta equals square root of 15 over 15. Now we just have to double check. Is that positive or negative? We're in quadrant 3. Tangent's positive there. You know why? Because those negatives canceled. It all worked out in our work. We're good to go. That's number 2. What? We have 2 more. You try each, and then I'll show you the solutions. Do the next 2 by yourself. Go. All right, so number 3 is right here. Sine squared plus cosine squared equals 1. And then we get cosine is 9/10, which means sine squared is 19 over 100. Check your calculator if you need your help. Take a square root. It's got to be negative though, right? Because it is in quadrant 4. So now we use the tangent ratio. It's sine over cosine. They give us the cosine that goes in the bottom. We computed the sine. We multiplied by 10 over 10. And guess what? We get square root of 19 over 9. It's got to be negative though. That's number 3. Number 4. Same thing, sine squared cosine squared equals 1. We move the 3/5 squared over, we get 16/25. Take a square root, you get 4/5. Got to be negative though, because we're in quadrant 2. Figure out the tangent, and we get negative 3/4. That's it. I mean, that's a pretty simple lesson. Here are your practice problems on page 831 and 32. 1 through 5, easy peasy, lemon squishy. Optional extra practice. If you're just not getting it, try the Mathia. It's not required, so we're not assigning it. But you can do it if you want to. This is Mr. Kelly in K-Town. Remember, it's nice to be important. It's more important to be nice. See?